Hello everyone, welcome to the live class. So guys, today we are having another very important session in which we are going to discuss the topic from quantum mechanics, and here I am going to consider the topic related to angular momentum operator. Some of the points related to eigenvalues we will consider here, as well as many important expressions related to which there are great chances that you can expect the questions in your upcoming exam. So I hope today's session is going to be helpful for all of you, and everything which we will discuss in today's session will get clear to all of you. But still, at any point of time, if you will have any doubt, you can let me know about it, and we will do the discussion about all those points. So we are just going to start the discussion. And I hope in the previous classes the discussion which we have done, that will be clear to everyone, but still if there is any doubt, you can let me know. Very good evening everyone. Okay, so now let's just start the discussion. First thing about the angular momentum operator is that if we are representing it with just L, okay, in that case how we can write L? So that will be equal to Lx I cap plus Ly j cap plus Lz k cap. Clear? In this case, Lx, Ly and Lz are the different components of angular momentum, okay. And when we solve the questions, or we are having questions in the exam, there we need to write the values of Lx, Ly and Lz. And to memorize the values of Lx, Ly, Lz, there is a trick. So you will not have to put extra efforts to memorize these values or to find them. In general, we all know that L is equal to R cross P, okay. R is the position vector and P is the momentum. Clear? So in this case, if you will solve their cross product, even you can get the values corresponding to Lx, Ly and Lz. But there is one trick, as I am telling you, and as per this thing, that whether you need Lx or you need Ly or you need Lz, you will directly be able to write that value. Clear? So if we are going to talk about Lx, see, you just need to observe the sequence, okay, and that's to in the cyclic order. You will move from x to y and then y to z and then after that z to x. Clear? So if I'm talking about x, clear, after that what will be there? Y, and after that z. So write it in sequence, y, z, okay, and write their corresponding momentum. So it's gonna be py and pz. Clear? Now what you will do, just do the cross multiplication. As we solve the matrix, okay, and we find its determinant, the way how we consider the order, okay, like we multiply this term diagonally with this one. So we'll write y pz minus this one with this one, you will multiply. So that's going to be zpy. So in this way, if you will be familiar with this fact that, oh, how I can write the Lx, Ly or Lz values directly, you will not have to solve it completely every time and it will save your time. Clear? Similarly, let's write the expression for Ly. After y, what will be present? Z, and after z, x. So z and x, write pz corresponding momentum, write px corresponding momentum to x, then cross multiply, you will get zpx minus xpz, okay. And similarly you can write for Lz. So Lz will be equal to what? Again, after z what we are having? X, and after x, that's y. So let's write it here, x, y, px and py. Clear? Now x into py minus y into px. Easily you can write these values. Clear? After this, what we will do? We are going to consider some of the commutator bracket expressions related to which there are chances you can expect the questions in the exam. So directly I am going to tell you the commutator bracket right now, and I hope you all know the general expression of commutator bracket, that anytime if you want to find the commutator bracket of A with B, two operators A and B we are considering, so that will be equal to AB minus BA. Clear? In general. Now you already know that what are the values or expressions of Lx, Ly, Lz we are having. So just by considering those values and just by considering the basic formulae of commutator bracket, you will be able to get these expressions directly as well. So if you want to solve them, you can even try that as a homework. Okay, and right now the expressions which I am going to tell you, they will help you to answer the questions directly and in very less time. So like the first one, Lx with Ly. If you want to find the commutator bracket of Lx with Ly, what you will get? You will get iota h cut Lz. Clear? Iota h cut Lz. Again here we are following the cyclic order. X, Y and then Z. Okay. So Lx, Ly commutator bracket will be equal to iota h cut Lz. There is one property of commutator bracket. If we are considering the commutator bracket of A and B, that will be equal to the commutator bracket, the minus sign and the commutator bracket of B with A. So if you are changing the order, in the final answer there will be a difference of minus sign. Clear? So if I will write Ly with Lx commutator bracket, I will get minus iota h cut Lz. Clear? So I hope you all know about that too. Now next expression if we are going to consider, that's gonna be Ly with Lz. Again you just need to follow the cyclic order sequence. Clear? So let's consider it. If I am talking about Ly with Lz commutator bracket, that will be iota h cut. Okay, you know x, then y, then z and then x. So y, z. After that what will come? X. So Lx. Done? It's simple and easy. You can directly write it. Again Lz with Lx. Okay, see the sequence, they are following the cyclic order. Firstly Z is present, then X is present, so next will be Ly. Clear? So we can write it in this way. And if they are not following the sequence, that means X present first, then Z present, that means in opposite way, so minus sign will be there if they are not following the sequence. Clear? Even with the property of commutator bracket, you can get this thing. If there is any doubt anybody is having till now, you can let me know, and if everything is clear, that's very good. Now next expression, if we are going to talk about the commutator bracket of L square with Lz, the commutator bracket of L square with Lz, what will be the value? It will be equal to 0. So even if you will put the value of L square, that will be equal to L square will be equal to Lx square plus Ly square plus Lz square, just by putting it. Okay, and by putting the value of Lz as we have already discussed in the starting, you will be able to get the overall commutator bracket value of L square with Lz equal to 0. As you all know, generally to show the operators, we put a cap on them. Clear? So if you want to put or if you want to consider, you can consider them in this way. Right now I'm just mentioning them directly, but for the safe side and just to have this as a habit, if you want to consider, you can consider a cap on all the terms which are operators. Clear? Don't worry about that thing that generally you get cap there and it's not present here right now, so you can consider it. If there is any doubt anybody is having till now, you can let me know about it. Exactly in the same way, if you will check the commutator bracket of L square with Lx or L square with Ly, okay, you will be able to get like the answer in the same manner as we are getting it for Lz, that's 0. Next thing, if we are considering the value of the commutator bracket of Lx with Px, that will also be equal to 0. Why? Because there is a property of commutator bracket, that is, if any function, let's say this is one operator x and its function is present with itself. Clear? And if you want to find its commutator bracket, it will always be equal to 0. So with this property, even you can consider that, oh, we will get it equal to 0. The commutator bracket of Lx with Px. If I am going to talk about the another one, Lx with x, that will even be equal to 0. Now I am going to ask you the value of the commutator bracket of Lx with y. Clear? Lx with y. You will let me know once that what will be the commutator bracket of Lx with y. Once you will get it, you can mention it in the comments and let me know about that. Kirti, if you want to find the commutator bracket of L square with R square, so what you will do, see, the L square you will write as Lx square plus Ly square plus Lz square, and along with that you will write R square as x square plus y square plus z square. Clear? If you are just taking the vector R square, done. And if you are taking its magnitude square, then accordingly you will put the value. And just in the normal way, you can separate out the terms by using the properties of commutator bracket, and then you can find it out. Clear? And there is one more property, that if there is the power of some operator present, you can write it as like its derivative first, then normally write the commutator bracket of both. Clear? You can even follow that property. Abhishek, if you are having some doubt about the Lx Ly commutator bracket, clear? In that case, what you will do, I am telling you that from basics how you can start it. Just put the value of Lx, which you already know in terms of yz, py, pz. I have already mentioned that value, that what will be the commutator bracket. But if you want to drive it, if you want to get it on your own, just put the values here, then get the final answer. Okay, so step by step you can proceed. Put the values of Lx, Ly in terms of x, y, z and px, py, pz, and then finally solve it by using the properties of commutator bracket. It will be easy for you. That's very good, everyone. Very good, Kirti. Very good, Yashika. Very good, Deepika. Very good, Meenakshi. And even there are some other answers like 0. Very good, Arpita. Very good, Sundar. Done. So guys, basically if you will find the commutator bracket of Lx with y, it will be equal to iota h cut z. Clear? And how we can drive it? It's easy and simple. You know how to, like, what is the value of Lx? So that's gonna be y, z, py, pz. How we can find it? Y into pz minus z into py, comma y. Okay. Then how we will simplify it further? Just by taking y pz comma y, okay, minus z py comma y. Clear? Now if you are going to simplify it more, what you will get? You know y with y commutator bracket will be 0. Pz with y will be 0. So from first term you will not get any value. And in this way, like in the previous class, even I have explained that how you can observe it and get the answer easily. Clear? For these kind of commutator bracket, just observe the order. Okay? So this is not going to give you any value. But if we are going to talk about z with y, we will get what? We'll get 0. So z with y combination or pair will not give us any value. It's just gonna be 0. But py with y will be minus iota h cut. So what we are going to get? Minus iota h cut and z. Because z was not giving any value if we were considering it with y. Okay. So final answer is what? Iota h cut z. That's gonna be how you are getting this answer. Done? Next, and by using these simple steps of commutator bracket, you can get the answer for any such commutator bracket question. Done? If still there is any doubt anybody is having in this discussion, you can mention and you can let me know about it. Okay guys, next question, that's L square with x commutator bracket. What should be the answer? L square with x commutator bracket. What you will get for this? L square with x commutator bracket. If you know the answer, you can mention. Otherwise, we are going to consider it. And we will discuss the steps that how we will get this answer, what will be the answer and all. And if you are having any doubt regarding this, what you can do? already we have considered L square with LZ, that's 0, clear. Now we are considering L square with X. So if you are having any doubt or confusion, write Lx square, okay, plus Ly square plus Lz square with X, and consider it step by step, and you can easily find by following these steps. Still, if there will be any doubt or difficulty, you can let me know, and if you are reaching to the final answer, you can mention it in the comments. That's very good, Kirti. Very good, Deepika. Very good, Vandana. So guys, finally we are going to get it equal to 0. But how? See, there is a property of commutator bracket that if we are having any operator to the power present, okay, here, and the other operator present like this, so we can simply write it n a to the power n minus 1 and commutator bracket of a with b. Clear? In this case, again, if I am going to consider that property, I will get what? I am going to get 2 Lx and the commutator bracket of Lx with x. As I have told you, if with the same function you are considering it, and even to get it in more detail, what you can do, you can put the value of Lx here. Done. What is the Lx value? As we have already discussed that trick, that how we will get the value of Lx, Ly and Lz. So you can put the value of Lx there, okay, and with each and every term you can try to find the commutator bracket. That will be simple and easy. Clear? And you will get finally that it's gonna be equal to 0. If anybody is having any doubt regarding this, or if you are facing some difficulty in getting this answer, let me know. We'll consider all the in-between steps as well, and if it is clear and if you can drive it on your own, that's good. Okay, you should finally get it equal to 0. So let me know if there is any doubt. Very good, fun with physics. Very good, Sudha. If there is any doubt anybody is having in this, please let me know. And guys, you can focus on the discussion, so don't worry about anything else. Is there any doubt in the discussion which we have done till now? Okay, let's consider next point. By knowing about all these commutator bracket expressions, okay, I hope now you know many commutator bracket expressions and their values related to angular momentum. Along with all these expressions, if there is going to be any other question related to angular momentum operator, clear? So in that case, you can derive it once you know the expressions for Lx, Ly and Lz. It will be simple and easy for you. Next thing we are going to consider is the raising and lowering operators, L positive and L negative. Clear? So these are also going to be the ladder operators, but in terms of angular momentum we are considering them right now. Also we will discuss their eigenvalues, that if we are operating them on some of the states, so what kind of answer we will get. Clear? So if we are going to talk about L positive, that's gonna be Lx plus iota L5. And if we are going to talk about L negative, that will be equal to Lx minus iota Ly. Done. So these are the expressions for Lx and L positive and L negative. Done. Now in this case, if we are going to talk about the commutator bracket of L square with L positive negative. Done. Now you know what is the value of L positive and L negative, so you can directly write it. Clear? In this way, if you are going to put the values of L positive, L negative here or L square here, what will be the answer you will get? It will be 0. for the exam point of view, like you should know how to drive the expressions, how to get the final answer. But for the exam, it is also very important that we all should memorize these expressions or the values, so that in less time we will be able to get the answer in the exam. Okay, you are just having the limited time there, just 3 hours. Okay, and in those 3 hours there will be many new questions which you need to consider, which you need to solve. So it's better wherever you can save your time, you should try to do that. It will be helpful for you. If I'm going to consider the commutator bracket of LZ, okay, with L positive negative, what will happen in this case? You will just get positive negative. If it will be L positive, you will get plus sign here. If it will be L negative, you will get minus sign here. So it's gonna be H cut L positive negative. Okay, and if you are someone who is solving such type of questions for the first time or getting to know about these expressions for the first time, what you need to do, you will try to solve them. Like you can consider it your homework. Like some of the expressions or their steps I have explained, in the same way you will try to get these expressions. Okay, and if there will be any doubt or difficulty in next session, you can let me know about it, and we will do the complete derivation wherever you will have some doubt or difficulty. Clear? Next, if we are going to talk about the commutator bracket of Lx with L positive negative, because you already know in the L positive or L negative expressions we are going to have the x and iota Ly term. Done? And we already know what will be the commutator bracket of Lx with Ly. Okay, we have already discussed that. So when you will put those values, because Lx with Lx commutator bracket will be equal to 0. So in this case, you will get your final answer as minus plus iota h cut Lz. Okay, and you all will try to get these expressions once if you are solving or getting these expressions for the first time. It will be good for you, like just for the sake of practice, even you can do it. It's gonna be good. Clear? If we are going to talk about the next expression, let's quickly consider that what will be the eigenvalues corresponding to L positive or L negative if we are going to put the values, okay, or applying these operators on some of the states. So I hope it's gonna get clear till this point. Is there any doubt anybody is having till this point in any of the expressions? If yes, you can let me know about it. Any doubt till this point? That's very good, Kirti. Very good, Sudha. Very good, Vandana. Okay, very good, everyone. Let's talk about the next expression. Okay, and every single expression which I am discussing right now in this video is very important. So don't just even miss a single point out of this. And once you will have an idea that how we are driving these expressions and how we are getting them, which you will try in the homework for some of the points. Okay, and after that, whatever questions you will get related to these points, you will directly be able to get the answer for them. Okay, it will not be a difficult thing for you. Let's talk about the next one. If we are going to talk about the operators L positive, and if we are operating it on some state having the values of L and M, let's say these kind of expressions will be given to you. Okay, L, M are having the same meaning as we consider like orbital quantum number. Okay, and like they are having usual meanings. It's not at all different. So whenever you are operating L positive on some state for which the values we are having L and M, okay, so in that case what answer you will get, or what will be the eigenvalue corresponding to L positive? So that's gonna be, see, positive means it's gonna increase the state. Okay, so it's a raising operator, and when I will talk about the L negative value, it will decrease. Clear? So L positive, the eigenvalue corresponding to this will be L minus M, L plus M plus 1, you have to memorize this expression, okay, so that anytime if you are solving some question, you will directly be able to use it. See, now what I will write now, it will show you how it's increasing the state. So it's gonna be m plus 1. So it was already just m, but when we have operated the L positive operator on it, we are getting m plus 1 here. Done. If we are going to talk about L negative and we are operating it on this state, okay, having the corresponding values as we have shown it here. So corresponding eigenvalue, see whatever term I am writing here now till h cut, so that's the eigenvalue of this operator, okay, for the given state. Now we will get L plus m into L minus m plus 1, L minus m plus 1, and now this time the value of m will get decreased by 1. And h cut will be there, L comma m minus 1. That's how you can consider it, okay. And wherever it will be required that you need to put some value, you need to consider the eigenvalues, so you can directly consider these things and you can get the answer wherever these things are required. If any doubt anybody is having, you can let me know till this point, like anywhere. Kuleshwar, the physical meaning of commutator bracket I will let you know. See, basically if we are talking about the commutator bracket, okay, A and B, clear? In this case, if we are getting the commutator bracket of A and B operators equal to 0, then in that case what will happen? In this case we can say, see, just to consider this meaning easily, I am going to tell you one thing here, that is commutator. If you are going to read that word, there is a thing you can consider commute, clear? Commute, from there you can consider communication, clear? In that case we can say that if any two operators are commuting with each other, that means we can find them simultaneously, okay? In any of the systems we can find them simultaneously, or you can say we can find them together. Now in this case, if I am saying there is an operator x and its function, corresponding function. So when we are talking about the operator x and its corresponding function, so in any system if I can find x at a moment, at the same time I can even find the function of x, any value if I want to find, clear? So these two will always commute with each other, clear? And that's the reason that why x with fx will be always equal to 0. Or if there is any constant and if you are finding its commutator bracket with fx or fy, you will always get it equal to 0. With any constant, the commutator bracket of any function will be equal to 0, because again with the constant we can find the value of any given function. So that's even b is going to be something that which tells us what is the physical significance of commutator bracket. So we can understand with these examples very easily. Any doubt anybody is having till this point? If yes, please let me know. Yeah, very good Kuleshwar, that's correct. The commutator bracket will be equal to 0. You have already mentioned that point. Very good Sayanika. Done? Okay, that's good. Next, one more guys. If we are going to talk about the operator L square, and when you are operating it on a state, that's gonna have the values n, L and m, clear? In that case, the eigenvalue corresponding to this will be L into L plus 1, h square, and the state remains same because it's not a raising or the lowering operator. So it will not change the state or neither the values of n, L or m, okay? None of the values will get changed. Another very important expression is if you are operating Lz on any state having the values n, L, m, okay? So you will get m h and n, L, m, clear? So these are the expressions and the values which we have considered, and we all should know about them because we will need them anywhere in any of the expressions. So these values should be clear. and if they are clear to you, you will simply be able to solve any questions based on angular momentum operator. If still there is any doubt anybody is having, you can mention. And thank you so much everyone for joining this session. I hope most of the things which we have discussed will be clear. मन्नू श्योरली लाइक नेक्स्ट सेशन टुमारो विल ट्राई ऑन पॉइजन ब्रैकेट, ठीक है. बहुत सारे एक्सप्रेशन और कोशिश करेंगे साथ ही साथ उस पर बेस्ड क्वेश्चंस प्रीवियस ईयर्स के कंसीडर करें, ठीक है. सो थैंक यू सो मच एवरीवन फॉर जॉइनिंग दिस सेशन. आई होप दैट ईच एंड एवरी पॉइंट विच आई हैव डिस्कस्ड इन टुडेज सेशन विल बी क्लियर टू ऑल ऑफ यू. बट स्टिल इफ यू विल हैव एनी डाउट anywhere in any of the points, you can let me know about it. We'll try to consider all those points, so don't worry about that. Even if you are having any doubt in any expression, and tomorrow even I will try to consider a session, okay, at the same time as we are having it today. And if there will be any changes, like yesterday I have informed you about it, okay, so I will provide you the information regarding that. Otherwise we are going to have the session tomorrow as well. Thank you so much everyone. Also guys, as you know, there are so many Unacademy Plus courses going on Unacademy Plus. हाँ, कीर्ति कल भी क्लास होगी, ठीक है. इसी तरह से सरप्राइज क्लास, मतलब कोई भी एक टॉपिक होगा जो कि इम्पॉर्टेंट होगा आपके एग्जाम के लिए, और उससे बहुत ज़्यादा चांसेस है कि आपको अपकमिंग एग्जाम में क्वेश्चंस मिल सकते हैं. ओके, सो गाइज टुमारो एट 7:20, एंड इफ देयर विल बी एनी चेंज in the session timings or session, okay, regarding the session, so I will inform you about it. Clear? Also guys, as you all know that there are going to be so many courses going on Unacademy Plus for your upcoming CSIR Net Physics exam preparation. So if you want to attend the more regular live classes by the top educators we are having on Unacademy Plus for your upcoming CSIR Net Physics exam preparation, then you can take the Unacademy Plus subscription. Also by using and by applying the referral code Anjali Arora, you will get the 10% discount in the total Unacademy Plus subscription amount. Clear? And as I have mentioned it here, you just need to write it as it is, no space in between, spelling should be same, write it, apply it, and get the 10% discount in the total Unacademy Plus subscription amount. After taking the Unacademy Plus subscription, you will get so many benefits like weekly quizzes, doubt clearing sessions, mock tests, PDF of important notes will be available to you, mock test analysis sessions will be there. So all these things together will help you to do very good preparation for your upcoming CSIR Net Physics exam. And you can even check out the courses on Unacademy Learning app, that what are the ongoing courses on Unacademy Plus, okay, what are the upcoming courses, and even if you have missed any of the sessions, you will get the recordings of those classes, so you will be able to cover up each and everything we have covered till now. You will not miss anything out of that. Clear? Thank you so much everyone for joining this session. Thank you. I hope that the sessions are helping you, and we will have more discussion in upcoming classes on many important topics. Thank you everyone.